Hello everyone. I'm using my cell phone. Oops. Okay, so I'm using my cell phone to record, and I'm using my laptop to see your chart. And this right here is just that we will go over my exam number 3 solutions for my students who just took my Calculus 2 exam today. And this exam is about power series, Taylor series, infinite series, the test for convergence, etc., etc. And of course, today I have the Pikachu right here. And don't worry, you know, Xiaotutu is right here. She's the audience for today, right? And if you guys would like to try the questions, you guys can go download the file. The file is in the description, so go ahead and do that. And we have, wow, 158 of you guys. Thank you guys so much for coming. And let's see. Hello, everybody. Hello, everybody. So I'm just reading your comments right now. All right. So hello, everybody. Hello, everybody. Okay. So Orange C7, I see Pikachu. I click. Thank you. And again, hi, everybody. And okay, Nick. Hello, hello. And okay, a lot of you guys. All right, so hopefully everybody's doing well, and let's just get right into it. I have 13 questions to go over, and I hope this is just going to be like an hour or so. And again, if you guys want to try the questions, you guys can also go download the file. The file is in the description. This is Calculus 2, right? About the test for convergence, all the stuff. All right, so let's get into it, and let me know if you guys can hear me okay. So can I just get some feedback first to see if you guys can hear me okay before I start? Can you guys hear me okay? Okay, thank you. Thank you, thank you. Audio's good. All right, perfect. I just want to make sure I don't want to be like last time where I was talking so much, but it was so echo. So thank you guys so much. Thank you guys so much. Thank you guys so much. All right, so now, first question. We have the series as n goes from 1 to infinity of 3 times negative 1 over 4 raised to the n minus 1 power. This right here is just like an open question for my Calculus 2 students. You can see that this is just a geometry series. And the best part is that, notice the r is negative 1 over 4. And the absolute value for that is less than 1. So that means this right here does converge. And we can totally find the sum of this. And to do that, the first term, you just put a 1 in here. 1 minus 1 is 0. Negative 1 over 4 to the 0th power is just 1. And we have 3 times 1. That's the first term. So this is the first term, is just 3 over. And then we do 1 minus the common ratio, which is negative 1 over 4. So that's the setup. And then, of course, you can just work this out. Here we have 3 over 1 plus 1 over 4, which is 5 over 4. And you flip that, you get 12 over 5. And that's it. That's the first question right here, right? So let's see the second one. For the second question, we would like to know which of the following series converge absolutely, right? So I'm going to write down the 4 series. So I will just put this down. We are checking for absolute convergence of the following. Choice A, we have the series as n goes from 1 to infinity of negative 1 to the nth power over inverse tangent of n. And then choice B, we have the series as n goes from 1 to infinity of negative 1 to the nth power. And choice C, we have the series as n goes from 1 to infinity, and we have negative 1 to the n over n squared plus 1. And choice D, we have the series as n goes from 1 to infinity, and we have negative 1 to the nth power over n factorial, like this. All right, and choice E is none of the above, so let me just put that down. None of this. None of these. All right, so you guys can take a look and let me know, what do you guys think? Which one converge absolutely? So I will give you guys about like 10 seconds. I would like to see what you guys answer. All right, a lot of you guys got D, which is great. The answer is D. That is correct. Right? The answer is D. That is correct. Well, let me just go over this real quick. Right here, to check for absolute convergence, what you do is you look at the series, and let me actually do this in purple. Of course, you guys know that. You always take the absolute value of whatever you have, right? So you have -1 to the nth power over n factorial. And when you take the absolute value, you see that -1 to the nth power doesn't matter anymore. And this right here is the series of 1 over n factorial. This right here does converge. And perhaps the easiest way that you guys can do this is the following. And this is what I teach my students as well. You guys should know about the list. And what I mean by this is actually for series, right? For series in this case. What I mean by this is the following. Well, we know that Ln is the smallest infinity as n goes to infinity. And this is less than n to the p's power. And this is less than b to the nth power. And this is less than n factorial. And then the biggest one that we have is n to the nth power. This right here is the usual list. But if you want to do the list for the series, what you do is you do the reciprocals, and then you just do the summation after that. So you can see you can have the series of 1 over Ln. And when you do the series and also the reciprocal, it becomes the opposite inequality. So you have this, and then you have the series of 1 over n to the p, and then this, and then the series of 1 over b to the n, and then this, which is, I run out of space. But you guys can see, this right here is actually pretty good because I'll tell you, the prime example of a series that being diverged is that you have the series as as n goes from 1 to infinity of n to the first power. If you look at this, I will tell you anything above this diverges, anything below, right here, anything that's smaller than this on the chart converge. So you know this right here converge if you remember what I told you about the list. So that's it, right? And maybe you guys can just in the comment and let me know. How about choice A? How come this right here is not absolute convergent? Anybody ready to say? Choice A is what? This right here is actually just divergent. How come? Because if you let n goes to infinity, this does not even go to 0, right? This right here actually diverges. Likewise, this right here also diverges. Because if n goes to infinity, this right here does not go to 0, so done. This right here, if you take the absolute value, that diverges. So this right here is actually conditional convergent. And in fact, one of the questions on the quiz, it's actually similar to this, right? And by the way, if you are my student, you guys can let me know in the comment down below. I don't know if any of my students are watching or not. They actually just took the test today, and I'm doing a live stream because, yeah, I just want to get this out as soon as possible for my students. All right, question 3. I'm talking about Pikachu, and I do have a Pikachu in my hand, right? Hopefully you guys all like this. Okay, Pikachu needs to find the radius of convergence for the power series, and it's this one. I'll put that down right here for you guys. Number 3, given the power series as n goes from 1 to infinity, and we have -1 to the nth power over n times 3 to the n times x minus 2 to the nth power. And what we want is the capital R, namely the radius of convergence. Well, how can we do this? N is squared. Thank you so much. In fact, it actually won't affect about our radius of convergence. But can you guys tell me the answer by looking at the equation right away? Hey Shin, I remember you, and thank you for coming. All right, I see some of you guys tell me the answer is 3. Some of you guys say the answer is 1. I'll tell you the answer is equal to 3. Here's a fast way to do it. You just have to check about the exponential part. This right here is 3 to the n. That's pretty much, you have the 3 and you are pretty much done. That's one cool way to do it. But of course, you still have the details. You have to make sure this right here is just n and all that stuff. But anyway, let's be slightly more legitimate. Right here, r is equal to, you can take the limit as n goes to infinity, and technically you take the absolute value and you do Cn over Cn plus 1. What's Cn, you may ask? Well, this right here is the Cn. Then you can just go ahead and do that. But be really careful though, because this right here is just n, so we can do that. If this is at 2n or 3n, you may have to take some square roots and all that. Anyway, let's go ahead and do this. Here we take the limit as n goes to infinity. I will put down Cn first. Namely, we have -1 to the nth power over n squared times 3 to the n. And then I will divide this by Cn plus 1. So I will just multiply by this thing's reciprocal, but all the n's becomes n plus 1. So I will get -1 to the n plus 1, and then this becomes n plus 1 squared, and then multiply by 3 to the n plus 1, like this. Now, here is the part. I'm going to fix all the big exponents right here, but actually this and that doesn't matter because in the absolute value world, they are just equal to 1. But if you look at this, this is the same as 3 to the n times 3 to the first, so this and that cancel each other off very nicely. All right, let's see what we have after that. This is the limit as n goes to infinity. Again, this and that, bye-bye. We have the absolute value. Actually, you don't need the absolute value anymore. You have this, n plus 1 squared over n squared times, here we still have the 3, but don't forget about that. So that's what we have. Now, have a look. The top right here, the biggest power is n squared, so you can just kind of pair this up. And then, of course, the bottom right here is just n squared, right? So all in all, if you worked out the limit of this, you just get 3. So that's the answer. Yeah, it's not as bad as you guys. It's not as bad as it looks like. I know some of you guys might be intimidated by the power series and Taylor series, all that, but it's not so bad sometimes. All right, number 4, we are going to go through a multiple choice question again. Well, actually, the first 6 questions are multiple choices. Number 4, we are going to find an example so that, oh, by the way, we help the Pikachu with this right here. It's 3, Pikachu is happy. All right, number 4. Which of the following is an example that we want the limit of n goes to infinity of an? This right here is equal to 0, but the series of an diverges. And then let me just not put down this because my board is pretty small and you guys have the file already, so let me just do that. All right, I'm just going to put down the choices for you guys. First one, an is equal to 1 over n factorial. Second one, an equals sine of pi over 2n. And then choice C, an is equal to 3 to the negative n. And then choice D, we have inverse tangent of n. And choice E, we have, oops, I should have put this down as an. I'm sorry about that. An equals inverse tangent of n. And the last one is 1 over square root of n, like this. All right, you guys do it. I'll give you guys about 20 seconds. All right, which one right here is that the limit of an goes to 0, but the series diverge? All right, a lot of you guys say E, and that's correct. And good, excellent. So the answer right here is E. So this is the reason why. This is an already. if you check, well, you are looking at the limit of n goes to infinity of this, which is 1 over square root of n. Well, put infinity to here, square root of infinity is infinity, 1 over infinity is 0. So you satisfy the first situation. But you have to make sure that the series, as n goes from 1 to infinity, if you put this right here, right, square root of n, this right here, square root is what? It's the same as 1/2 power. This right here diverges because the p is 1/2, which is less than or equal to 1, right? So that's pretty much it, right? Choice A is not the answer because it goes to 0, an goes to 0, but the series of an converges. This right here, the limit doesn't even exist. So the second part is diverge. Third one, well, the limit goes to 0, but this right here, the series converge. And this right here, shall I write this down? Do you guys want me to write this down, or you guys are okay? All right, you guys are okay. So, all right, okay, cool. And then lastly, if you let n goes to infinity, inverse tangent is pi over 2, right? If you approach that to infinity. So that doesn't even give you 0. So none of this work except for E, and then you are done, right? And by the way, if you guys have taking the AP calculus test tomorrow, best of luck to you guys, and thank you guys so much for coming to this. So I think it's kind of good too. You guys are, watching the live streams. You can do some infinite series as well. All right, great. Now, the next one, we are going to do some question with our best friend, which is that we are going to determine the power series for the following. So this is number 5. We want power series for the function 5x squared over 4 minus x. And also the r and I. Radius of convergence and also the interval of convergence, right? So what do you do with this? If you want to find a power series of a rational function, what's the thing I'm going to tell you guys to do? Let me see what you guys will say. How are you guys going to find the power series of a rational function? Use the best friend, that's right. So I'm mad. EMAT. I'm sorry, I don't, but like, great, you guys know. Yes, that's the technique that we'll be using. We will be using our best friend, right? You don't have to go through a Taylor formula, that will be slightly overkill, because if you have a best friend, what do? Use it. Definitely, right? So now, let me put down what we know. We know our best friend, which is 1 over 1 minus x. Yep. This right here is equal to the series as n goes from 0 to infinity, and you have x to the nth power. And you also have to remember the absolute value of x has to be less than 1. All right, this is what we have. So let me write that down. We have 5x squared over 4 minus x, like this. Now, in order for us to use our best friend, we must have a 1 on the top. But this is 5x squared. So put that aside. Put that right here, right? So put a 5x squared right here first, right? So we can, of course, write this as this times 1, like that. Good. Next, in order for us to use the best friend, this right here has to be 1, but this is the 4, so we have to factor out the 4. So I will just put this as over 4, and then we will have this right here will become the 1 that we want, and this is a minus already, which is perfect. But here, originally, we only have x. We factored out the 4, so this becomes x over 4. So this is 1 over 1 minus x over 4, like this, right? With that said, you see, here we still have the 5x squared over 4. But this, we can totally just use our best friend now. So put this in here. We have the series as n goes from 0 to infinity. And then put this right here. We have a parentheses, x over 4, and then raised to the nth power, like that. In the meantime, don't forget to put down the absolute value of this inside, which is x over 4, and you have to make sure this is less than 1, right? And then we are just going to simplify the rest, and that's pretty much it. All right, so now have a look right here. I'm just going to work this out for you guys. N goes from 0 to infinity. First, let me put this down. We have x to the nth power. Let me just put that down on the side. Yep. And then we have 4 to the nth power on the bottom. So we have this over 4 to the nth power. But we are not done yet. You see, we have the 5. We are going to multiply that in. So we have the 5 right here. X squared, we also multiply that in. So this becomes the plus 2, like that. So perhaps I will just put down the 5 in red as well. Lastly, the 4 multiply in. So you have the n plus 1, like this. And that's your form. That's it. That's your best friend right there, right? Well, right here, you can also solve it real quick. The absolute value of x over 4, you can just put the 1 over 4 to the front and multiply the 4 on both sides. So you're looking at this as absolute value of x is less than 4. And you will see r is equal to 4. And because the center is at 0, so the I goes from negative 4 to positive 4. And remember, you do not include the endpoints of the best friend, right? So you just put down the open parentheses. And again, all we did was just the algebra. So the convergence at the endpoint stay open, just like that. So that's it. So that's the first page right here, right? Now let's do another one. All right, number 6. This is the last question of the multiple choice. And I will just ask you guys, what do you guys think? 1/3 plus 1 over 6 plus 1 over 9 plus 1 over 12. If I just stop right here, can you guys tell me what the answer is? Nobody wants to add the fractions? 1 over 15, is it? I don't know, actually. All right, this right here is actually pretty hard, huh? If you have to add the fractions, but I'll make it easier for you guys. Put on the plus and dot, dot, dot. And now this becomes a calculus 2 question. All right, this right here, what's the answer for it? Anybody? Pikachu, do you know the answer for this? Okay, he knows. All right, infinity, that's correct. So if you guys look at this, if you want to be fancy, you can put this into the sigma notation. And this is the series as n goes from 1 to infinity. Everything on top is 1. And this is just 3 times whatever the n value is. And if you would like, you can factor out the 1/3 in the front. And then you have the series n goes from 1 to infinity, like this. And this right here is infinity. Or you can also say diverges. And then 1/3 times infinity, of course, is still infinity. And you are done, right? So that's it. Still infinity. Infinity divided by 3 is still infinity. Yeah. All right. Now the rest are the open-ended questions, and they will take some time for some of the questions. And this is mainly for my students, so I will still show some details for them. And also for the students who are taking Cal 2, hopefully you guys can find this to be helpful. And yeah. Okay, here we go. Number 7. Converge or diverge. Here is the series that we have. We have 2 over 1 minus 4 over 2 plus 8 over 6. And then we have minus 16 over 24 and plus 32 over 120 and minus and so on, so on, so on, right? So hopefully you guys can see okay. Converge or diverge and tell me a reason why. Pikachu is waiting for you. All right, Jeffrey, you got it right. Yes, it converges by the ratio test, right? And Noah Kuber, you also got it right. It's e to the second power. I think you missed the negatives as well, so it's not quite. Yeah. It's not converged by the lists, right? All right, so now let's go ahead and do this. Converge or diverge. Perhaps the best thing for us to do now is to put this into the sigma notation. So I'm just going to write it. And you have choice. You can let n start with 1 or 0, up to you. I will just do it with 1 to infinity. Now, have a look. We have 2, 4, 8, 16, 32, and so on, so on, so on, right? So on the top is just the power of 2, yeah? Also, you notice that the first term is positive, and the next term is negative, and then positive, negative. So it alternates. So what I can do is, I can write it down as, let's say, negative 1 to the n minus 1 power, because the first term is positive, and n start with 1. Yep, so we have this term first. And then the numbers, I will just put it as 2 to the nth power. 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and so on, so on, so on. And then the negative will be taken care of by this. On the bottom, this is 1. This is 1 times 2. This is 1 times 2 times 3. This is 1 times 2 times 3 times 4. 1 times, it's 5 factorial, you know that. So you just get over n factorial. So change that and you should have this right here. So now, I will just tell you, let's go ahead and use the ratio test. Okay, can somebody tell me why it's a good idea for us to use the ratio test? I'll be checking out your comment and I will try to say your name out loud too. Why do we use the ratio test? What's the hint that lets you use the ratio test? Andy, you got it right. There is factorial and also exponents. Perfect. Whenever you see the n in the exponent and also the factorial, it's a great idea to use the ratio test, right? So here we go. I'm just going to write this down like this. As n goes to infinity, we are taking a limit, and all we have to do is this. You first take the absolute value, and you do an plus 1, all right? It's the different than the radius of convergence formula. Right here, I'm just going to put it down as negative 1 raised to the n plus 1, and then minus 1 power, right? That's what we have here. And then times 2 to the n plus 1, and then divided by n plus 1 factorial, like this. Times the reciprocal of the original. So here, we just get n factorial over negative 1 to the n minus 1 times 2 to the n, like this. And now, when you have negative numbers instead of absolute value, doesn't matter. So this and that, don't have to worry about it. But look at this. This is 2 to the n times 2 to the first. This and that cancel each other out very nicely. Great. And let's also break down the big factorial, which is this. To do that, we get n plus 1 times the next term, which is n, and the next one is n minus 1, and so on, so on, so on. In another word, this is just n factorial. And yes, we can cancel this one out with that. Excellent. So now, based on the algebra, so that's why I'm still putting an equal sign. Don't worry about the absolute value. I will get rid of this and that. On the top, I still have a 2. On the bottom, we still have the n plus 1. Right? So that's a simplification that we got. And then don't forget, we still are taking the limit. N goes to infinity. You put the infinity right here. 2 over infinity plus 1. This right here will approach 0. Does 0 do us any good? What does the 0 tell us? Again, type in the section. Comment sections, I will see what you guys have. Great, so Harrison, you got it right. This right here, it's the L, which is 0. And more importantly, you have to notice this right here is less than 1, right? 0 is less than 1. And that's good for us to use in the ratio test situation. So I will tell you the whole thing. I will just write this down right here again. The series as n goes from 1 to infinity, negative 1 to the n minus 1 times 2 to the n over n factorial. And technically converges absolutely because we have the absolute value right here. But you can just say it converges. And again, be sure you quote the reason by the ratio test. And you are done, just like that, right? All right, so now for the next one, we are going to do some integrations. But don't worry, no integration by parts needed, no like partial fraction, no whatever. We just need to use power series to do integrations. So number 8, this is the first one. I'll just write down the direction for you guys. Integrate as power series. This is the first one. Here we have the integral ln of 1 plus x to the third power over x, and then, yeah, and then dx that. We are going to integrate this as a power series. All right, so now it's just a matter if you guys remember the power series of the natural log or not. If you don't remember it, you might have to derive it like from scratch. But I do remember it. So I'll put that down right here for you guys. So I'll just write this down right here, right? So this is natural log of 1 plus x. This right here is equal to the series as n goes from 1 to infinity, and well, actually 0 goes to infinity. I'm using this version, right? 0 to infinity. And here we have n plus 1. On the top, we have the alternating version, so it's negative 1 to the nth power. And here we have x to the n plus 1, like this. And I will also have to tell you the absolute value of x right here is less than 1, right? So I'm sorry about my little board right here, but this is the power series for that. Anyway, let's do this. ln of 1 plus, here we have the x to the third power. And then we have to divide this by, sorry, not the x to the third power, I'm sorry, this is the x to the third power. I meant to do the 3x. So the question right here is meant to be 1 plus 3x. 1 plus 3x. And then right here, ln of 1 plus 3x. And then divided by x. So let's see what the power series is for this. Well, we have the 1 over x. I will just put that in the front for now. And then ln of 1 plus 3x. We can just put the 3x in here, which should be red, like that, right? So I will just write down the series as n goes from 0 to infinity. Here we will have negative 1 to the n over n plus 1, parentheses with 3x inside, and then raised to the n plus 1 power, like that, right? So that's what we have. But be sure you also include the absolute value, but let's see. Let me just put that down right here. Absolute value of 3x has to be less than 1, right? Absolute value of 3x has to be less than 1. That will tell us the radius of convergence. All right, here, I'll just work this out. Here you see we have the series as n goes from 0 to 1, 0 to infinity. Don't worry, I haven't forgotten about the 1 over x. But here we'll just write it as negative 1 to the n. This is 3 to the n plus 1. Yeah. This is the 3 to the n plus 1. And then on the bottom, we have over n plus 1. And here, you see, we have x to the n plus 1, right? However, we do have the 1 over n right here. So perhaps let's just still write it down so you guys can see better. This is the 1 over x. When you multiply this with that, well, they cancel out. So this right here, let me just write it down one more time. This is the series as n goes from 0 to infinity. Negative 1 to the n times 3 to the n plus 1 over n plus 1. This is like the negative 1 power. Combining with that, we just get x to the nth power like this. Are we done? No, this is just the power series. Even worse, we haven't figured out the radius of convergence yet. Anyway, put the 3 on the outside, divide both sides by 3, you see absolute value of x is less than 1/3 for this power series right here, right? So just keep this in mind. Now, here is the deal. Let's go ahead and integrate this. Integrating this, right? Integrating the blue part, I will just write this in blue, which is ln of 1 plus 3x over x, like this, and we have the dx. This right here, we know the radius of convergence is 1/3. So we will just actually include that right here right away. And remember, when you integrate a power series, the radius of convergence stays the same, which is very good. Now, this is the integral. Put the summation right here. We get the sum as n goes from 0 to infinity. And then we have -1 to the n, 3 to the n plus 1 over n plus 1. And then we have x to the nth power, like that. And then let's put on the dx right here. Man, integrating power series is the best thing to do, isn't it? Yeah, I don't know how many guys like integrate power series. You know, I can integrate 100 power series for you guys all day long. All we have to do is just add 1 to the power right here, and that's the new power. Don't forget to divide it by the new power right here. So I put down this right here. That's it. In the end, don't forget, you still have the constant, which I will just put down c plus, and then you just write this down again. So the series, n goes from 0 to infinity, and then we have -1 to the n, 3 to the n plus 1 over n plus 1 square, and then this is x to the n plus 1. Just like that. And the radius of convergence stays the same. So r is equal to 1/3. And we are done. So let's put the box right here. So that's it for that. I'm just doing the radius of convergence, and it's a test. So usually I would just tell the students to include the radius of convergence. That's it. Because if you want to do the interval convergence, that may take too long, you know. So depends on what the question is asking. All right, so that's what we have. Right? So take a look. Take a look. All right, for the next one, I would actually like to erase both boards. I would like to start right here, right? So here, I will just put this down right here. Because for this question, I will need 2 boards for that. Next one, which is part B, we are going to integrate sine of x squared dx. This is not the Fresnel's integral. It is the Fresnel's integral, but we cannot do that for now. We will use power series, which is okay. Here's the deal. This is what we know. Sine of x is equal to the series as n goes from 0 to infinity. And this is how I remember it. Sine, cosine, they are both alternating. So we still have the -1 to the nth power. And remember, sine is an odd function. And you will have the odd factorial here and also the odd powers. So let's write down 2n plus 1 factorial this, and then you also have the x to the same power, which is 2n plus 1, like that, right? Here's the best part for you guys. The radius of convergence is infinity, so you can just include that. This is the best because you don't have to check the endpoints, and then it's just always infinity. All right, let's look at the power series for sine of x squared. Well, for this, we just have to put the x squared in here. So we have the series, n goes from 0 to infinity, -1 to the nth power over 2n plus 1, factorial that. And then with the x squared inside, raised to the 2n plus 1 power, right? So that's that. Oops, no, this. Why am I using my fingers? I don't know. R is equal to infinity, like that. All right, let me just clean this up a little bit. So this right here is just the series as n goes from 0 to infinity. -1 to the n over 2n plus 1. Factorial this, and then we have x. Multiply the powers. So 2 times all that is 4n, and then 2 times this is plus 2, like that, right? So that's pretty much it. Now, to integrate this, I will just tell you, integrate, focus the sine of x squared dx. Well, we just have to integrate that power series, namely, series as n goes from 0 to infinity, -1 to the n over 2n plus 1, factorial that, and then we have the x to the 4n plus 2 dx that. Man, I want to speak up for power series at this right now with you guys. A lot of people don't like power series, and I will tell you why. It's because we just have to write down a lot of the same thing over and over. That's why. Because I wrote this down like 1, 2, 3, 4 times. But the only thing that we're doing is just plugging and then fix the exponent. That's it. It's actually supposed to be really nice, but people don't like it because they had to write this down so many times. Pikachu likes it, okay? So just give power series a chance. Don't hate on power series, please. Yeah? Okay. Good, see? Right. Anyway, right here, integrate this. I just have to add 1, and the new power is 4n plus 3, and I will have to divide it by that, so 4n plus 3, just like that. All right, so all in all, we get what? Well, don't forget the c plus first. And then we have the series, so you have to write this down again. N goes from 0 to infinity, and then we have -1 to the nth power over. Usually we put this down in the front, so we have the 4n plus 3. And then any part with the factorial at the end. And then of course we have x to the power of 4n plus 3, like that. What's the radius of convergence? Still infinity. Because when you integrate power series, the radius of convergence does not change. So that's what we have. Okay? Just like that. Hello? Hello. The power of Pikachu, that is correct. And for the people who are here, thank you guys so much for coming. I have a total of 337 of you guys. Thank you guys so much. I think this is the biggest live stream I've ever done so far. So thank you guys so much for coming up. And right now it's 9:13 p.m. So what time is it over there in your country, in your place? Let me know. 9:13 p.m. right now. So what time is it over there for you guys? 1 a.m. What country is it? And then 1:13. Whoa. 6:30. Whoa. 9:43. Let me know the countries as well, so I will see. 1 a.m. in Brazil. Okay. India. Okay. Greece. 7:13. Okay. Wow. 7:13. Okay. Great. Hi. Also, Xiaotutu wants to say hi for everybody. Thank you guys so much for coming. She is really appreciate you guys coming. Thank you guys so much. Thank you so much. And again, today we have Pikachu. Pikachu microphone. All right, let's do math. All right, number 9. This is going to maybe some of you guys may be mad, maybe upset or whatever for my students. Converge or diverge, right? So I'm writing this down. We are going to have the series as n goes from 1 to infinity, and we have cosine third power of 1 over n like this. So converge or diverge, right? Leave your comment, leave the answer in the comment. Oh, do we have Pyam here? Is that right? Is Pyam in the chart? Wait, do we have Dr. Pyam here? Seriously? I don't know. But anyway, converge or diverge? So leave your answer in the comment right now. All right, I have a lot of people say it converges, it diverges. Maybe we need to ask for Randy for help. Randy, what do you think? It diverges. It diverges. It diverges. It diverges. Right? Okay. Thank you guys so much. Thank you so much, Randy. All right. So this is how you have to do it, right? I will just tell you. Perhaps I'll use blue right here. Actually, no. I will just use this. All we have to do is use test for divergence. What do we mean? Well, we just have to check the limit as n goes to infinity of this, which is cosine to the power of 1 over n, like that. If you put infinity to here, and of course you can just do this real quick. You don't have to be too fancy on that. This is pretty much cosine to the power of 1 over infinity, and this is cosine to the power 1 over infinity is 0. What's cosine 0? It's 1. So the power of that is still 1. You see the limit right here gives you 1. So what does that mean? You have to know that 1 is not equal to 0. Right? 1 is not equal to 0. Therefore, you are done. This right here diverges by test for divergence. So just write this down. Conclusion, the series n goes from 1 to infinity. Cosine to the power 1 over n diverges by TFD, right? TFD. It sounds like team bracket, but no, team for diverge. Right? So it's just like that. All right, number 10. It's a fun one. I just want to see how my students are going to answer. So maybe you guys can do this as well. Part A, I asked you guys to write down your favorite sequence and put down the first 5 terms and tell me why. Part B, I'm asking you guys to tell me your favorite convergence series and what does it converges to and tell me why, right? So this right here, number 10. So A, I will just write this down. What's your favorite sequence, right? And tell me the first 5 terms and tell me why. Anybody want to share? And also tell me why. All right, so Errol, your favorite sequence is 1, 2, 3, 4. Perfect. One, 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 one. Chen Yu Kai. I think that's how you say it. I'm sorry, my Chinese is bad right now. So, but yeah. Mu prime math 2, 4, 2, 4, 8, 16, and then 31. I know that one. That's a very nice one. And then what else are you guys telling me? Fibonacci sequence. All right, cool. So the purpose for this question is just I want to see if the students know the difference between what a sequence is and what a series is. So, my favorite sequence, I don't know. Oh man, what did I say? All right, my favorite sequence, I will just say 0, 1, 0, 1, 0, and so on, so on, so on. These are the first 5 terms. Why? Because it's easy. Easy and fun. Why? Because you can actually come up with a lot of formulas to describe 0, 1, 0, 1, 0, 1, and so on. And you can also make it more difficult, 0, 0, 1, 0, 0, 1, 0, 0, 1, and so on, and then come with a formula of that stuff. Anyway, for my students, as long as they write down a legitimate sequence and explain why, and you have to tell me that there's a pattern between the numbers here, that's pretty much all they have to do. Part B, your favorite series. All right, and what does it converge to, and all the stuff. Anybody want to share your favorite series? I'm reading at your chart right now. Now you have to give me a specific one. You have to give me a specific series, and you also have to tell me what it converges to. You have to give me a convergent series, right? Your favorite convergent series, and you have to tell me what it converges to. Lucas, you said 没有 series? And what does it converge to? No, you. No, it's an infinite series, so you cannot just put in 1 plus 2 plus 3 plus 4 plus 5. And again, for the people who are taking AP test tomorrow, best of luck. Oh, here's a very fun one I saw, and I like that one too, right? So you can just write down 1 over 1 to the 4th power plus 1 over 2 to the 4th power plus 1 over 3 to the 4th power plus 1 over 4 to the 4th power plus 1 over 5 to the 4th power plus ... This right here converges to pi to the what? Anybody know? 4th power over 90. Why? Because it's cool. And notice, when you have a series, you add a bunch of the numbers, and these numbers have a pattern. When you have a sequence, you just pretty much list out the numbers. So that's the main difference between a sequence and a series. But of course, a lot more can be said. This right here is meant to be an easy question, and I just want to test out students to see if they know the difference between a sequence and a series. All right, 3 more questions. Number 11. Here we have the series as n goes from 1 to infinity. 1 over n times the square root of 1 plus ln n. All right? So this is the series that we have. Does it converge or diverge? And tell me why. All right? So I'll check in the comment section now. Leave your answer right now. I give you guys about 20 seconds. Converge or diverge, and why? In the meantime, I'm going to erase the board right here. All right, I see 2 people say converge, converge, converge. A lot of people say converge. You are correct, TFD does not work. And also tell me why. Don't just tell me like it converges or it diverges. You have to tell me the reason as well. Right, Pikachu is counting on you guys. Diverge because it's cool. All right, Alphonse. I'm sorry, I'm going to pronounce your name wrong. But the integral test. Integral test. Yes, yes, yes. Right. So this right here is actually diverges, and we'll use the integral test. So I will just say, let's use the integral test. And this is what you do. You are going to check the convergence for the integral going from 1 to infinity of 1 over. You check its corresponding improper integral. You change the n to x, right? So you have x, and then you have 1 plus L. But do not change this n to x. It's L n x, like that, all right? Like this. Do not put down LXX. Yeah, not like a funny joke, but whatever, I try. Anyway, besides that though, be sure you also include a picture or any kind of reason of this function. And if you graph this, you end up with a picture that looks like this, I believe. So graph that, you guys can see 1 over x square root of 1 plus ln x. X cannot be 0, right? And well, actually, x cannot be some number here as well, negative something, but like whatever. Anyway, when x is bigger than 1, you will see that it's decreasing for sure. And you will just say it's decreasing, continuous, and also positive. x cannot be e to the negative 1, right? So it's somewhere right here, but don't worry about that. Just want to do the test, integral test. All right, here we go. Right here, we let u equal to 1 plus ln x. And differentiate both sides real quick. We get du equal 1 over x dx. And I would like to isolate the dx, multiply the x on both sides. So we get x du like that. Now have a look. Remember, these values are in the x world. So don't forget to take them into the u world as well. Here we have the integral. Put the 1 in here, ln 1 is 0. So u actually goes from 0 as well. I mean, 1. 1 plus 0 is 1. Put the infinity here, L infinity is infinity, plus 1 is infinity. So the numbers are staying the same, right? That's good. Anyway, we have 1 over x times the square root. This inside is the u. And then dx is x du, like that. And we'll finish everything in the u world because you see the x cancel off very nicely, right? So you see that this right here is nicely equal to the integral 1 to infinity. We'll write this as u to the negative 1/2 power, and we are in the u world. So be sure you add 1 to the power, which is going to be 2 over 1 divided by, you add 1 is positive 1/2, but divided by the new power, which is just multiplied by 2 over 1. And then here is the big integral sign. And then you have 2, and then u to the 1/2 power, which is the square root of u, right? And then you just plug in numbers, 1 and infinity, and you can just do this real quick. Plug in infinity, you have this. And then that's the first part. And you are going to minus the second part, 2 square root of 1, like that. All right, this is infinity. That's just 2. So you still end up with infinity, and that diverges. That means the original series, right here, I'll just put on series as n goes from 1 to infinity, 1 over n square root of 1 plus ln n. This right here diverges by the integral test. And then with that, we are done, right? So take a look, take a look, take a look. Wait, man, is that, I'm back, but like, was he okay? But anyway, I'll just run through this real quick. You just go through all the integration steps, and you'll see that the integral is infinity. So that means the infinite series diverges by the integral test, right? All right, perfect, we're back, and then this is it. So just have a look at that, and that's it. So Pikachu is saving us, right? All right, number 12. So just 2 more questions, but number 12 has 2 parts. So here we go. Number 12, I'm giving you guys a sequence first. So an is just 1 over 8, and then 1 over 15, 1 over 24, 1 over 35, and so on, so on, so on, dot, 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 like that. First question, does an converge, right? So question 1, does an converge? And if so, to what value? Right? 20 seconds. Does it converge? An converge. Does it converge? Converge to 0? Good. Anybody can tell me a formula? All right, anybody can tell me a formula for an? Let's see who can do it fast. Oh, the dash. I missed it already. So it's yes, 1 over n plus 1 and n plus 3. That's correct. So have a look. This is 8, which is the same as 2 times 4. This is 15, which is the same as 3 times 5. This is the same as 4 times 6. This is the same as 5 times 7. So notice an has the formula 1 over, let's let n start with 1. So this is n plus 1. And this is just 2 more than this, which is this, just add 2 to this, which is n plus 3. Like that, right? And if you take the limit as n goes to infinity of this, which is just the limit as n goes to infinity of 1 over n plus 1, n plus 3, this right here, and you don't really have to show too much work. This right here will give you 0 if you put that down. So just say an does converge and converges to 0, and then after that we are done, right? Now part B, does the series as n goes from 1 to infinity of an converge or not? Let's see who can do this fast. 20 seconds. Let me see, who do I have to bang? Let's see. All right, so well, it does converge, but I would also like to know the value. So anybody can tell me the value? It does converge. Let's get to work right here, right? So here's the deal. We have to do the series as n goes from 1 to infinity. An is that, so we have to just do 1 over n plus 1 times n plus 3, like this, yeah? And I will just write this down right here for you guys. This is the series as n goes from 1 to infinity. We can do partial fraction for this. And because this right here, you will see it's actually telescoping. Right? So here's the deal. Do the partial fraction. I need to figure this out. I will come to the original and I will cover this up. Well, how can I make n plus 1 equal to 0? N has to be negative 1. So I'll put negative 1 right here. So I have to do 1 over negative 1 plus 3, which is just 1/2. Yeah? And similarly, to figure this out, I will come here and cover up the n plus 3. N has to be negative 3. Put negative 3 right here. We get 1 over negative 2, so it's negative 1/2, like this, right? Now, let's do the fast way, right? But I will clean things up. We have the 1/2. We will put that all the way in the front, like this. And then we have the series. N goes from 1 to infinity. First, we have 1 over n plus 1, and then this is minus, and then we have 1 over n plus 3, like this. This is how you can do it the fast way. All the way in the front, we have the 1/2, so just write that down. We have the 1/2, yeah? Now, notice that n plus 1, n plus 3, they are off by 2 terms. So what you can do is put 1 in here, so you get 1/2. So that's the first term that you have. And then you also have to have another term. Put 2 in here, so you just get 1/3. You see 2 terms in the front, but in the meantime, you also have to have 2 terms in the end. This right here is the last one, just minus 1 over n plus 3. And the term before that, which is just 1 less than that, 1 over n plus 2 then. So just like this. But don't forget, we still have to take the limit. So this right here, if you find the nth partial sum, this is the partial sum formula, and you still have to take the limit as n goes to infinity. The good thing is that this and that, they both go to 0 as n goes to infinity. So you just have to work out 1/2 times 1/2 times plus 1/3. Let me see if I can do this in my head. This is 5 over 6, and that's 5 over 12. Am I right? Let's see. Yes, 5 over 12. So this right here converges and converges to 5 over 12, right? So by telescoping, and that's it, right? All right, now I have just one more for you guys. Last one for tonight. Last one for tonight. Right, so just take a look again. All right, good. Last one for tonight. You might notice we haven't talked about the Taylor formula. Hey, King Arthur. I know you are like doing live stream earlier too, and then thank you for coming. Last question. We are going to find, so I'll just write this down. Find the third degree Taylor polynomial for cosine x at x equals pi over 4. Right? And you just have to work this out, that's all, right? So here we go. I think I will put this down in blue. All right, third degree Taylor polynomial. First, you have to have the n, and we have to go to where? Let's see. So we have to go 0, 1, 2, 3, right? Third degree, so we have to have this. And then here, this fn of x, and then at the end here, we put down the Taylor formula. Sorry, technically I should say A, right? This right here should be A. That's the center. And then I'm just going to put down pi over 4 here, and then divided by n factorial, like this. All right, originally we have cosine x. Differentiating this, we get negative sine x. Do it again, we get negative cosine x. Do it again, we get positive sine x. Having fun, huh? Now, cosine and sine of pi over 4, they are both 1 over square root of 2, which is very nice. That's why I chose this number here. Anyway, put this right here, we get positive 1 over square root of 2, but we have to divide it by 0 factorial. So just divide it by 0 factorial, which doesn't matter, it's just 1. Next, put this in here, we get negative 1 over square root of 2 divided by 1 factorial. Again, doesn't matter, 1 factorial doesn't matter. Next, we are going to put pi over 4 in here. This is negative 1 over square root of 2 over 2 factorial. And it doesn't matter now. I'll be really careful with that. Lastly, put this in here, we get positive 1 over square root of 2 divided by 3 factorial. Right? So that's pretty much what we have. So finally, I will tell you cosine x. This is approximately equal to, first, we have 1 over square root of 2. So I will put that down in blue. 1 over square root of 2. And this is just a constant term, right? Next, we have the negative, and this is 1 over square root of 2 over 1 factorial, which doesn't matter. We have this times x minus the a value, which is pi over 4. So let me just put down pi over 4, and this is to the first power. Next, you have this. So I will just put down minus, we have a 1 on the top, over 2 factorial is 2. That goes right here as well. So 2 square root of 2. And then we have parentheses, x minus, we have the pi over 4 again, and then raised to the second power. And lastly, we have that. And that's a positive, so I'll say plus. 3 factorial is equal to 6, because 3 times 2 times 1 is 6. And then you put that right here. We have 1 over 6 square root of 2, and then we have the rest, which is x minus pi over 4 to the third power. So if you remember the Taylor formula, you can just work that out, and that's it. This right here is the answer for that. So we'll box everything right here. And notice how I use approximation, because it's meant to be approximations for cosine x at pi over 4, right? So that's pretty much it for the test. And again, if you guys want to try the test, you guys can go download that. The link is in the description. And thank you guys so much for coming. And before we go, Pikachu wants to give a deep thanks to everybody who came here today. Thank you so much. Thank you guys so much. Thank you guys so much. And perhaps I want to thank Randy for helping us out earlier as well, right? And of course, Xiaotutu is here. So the powerful trio, right? They have to go back to their Pokeball right now. So I'm sorry. All right, you guys go back to the Pokeball right now, right? Yeah. All right. Anyway, that's it. And do you guys have anything that you guys want to talk about? Oh yeah, if you are taking your AP Calc test tomorrow, or just hold it like this. If you guys are taking your AP Calc test tomorrow, best of luck to you guys. And that's it. As always, hopefully you guys all like this video. I will see you guys next time. If you guys would like me to do more live stream like this, leave a comment down below and let me know, right? So, bye. Bye everybody, bye everybody, bye everybody. Bye.